Graphing rational functions. So this can be kind of complicated just because there's a ton of information into one graphing, into one thing. So there's four kind of steps. You don't necessarily have to do them in this order, just as suggestions. But graphing rational functions, one, find the x and y intercepts. Homework may call them horizontal and vertical intercepts, which is annoying, but there you go. Find the vertical asymptotes. We won't do holes in this class, but just remember that they exist. Find horizontal or slant asymptotes, and then plot at least one point between and beyond each x-intercept and vertical asymptote. Then basically finish your graph by just connecting the dots. Bear in mind that, right, we talked about parent functions, y equaling 1 over x. This looks like this. Oop, not my best drawing. Here we go. Z equaling 1 over x squared. Remember that it looks like this. Just so having these little things kind of to be able to call on will make your life easier. But we'll keep moving. So example 4. Oops, wrong button. There we go. Example 4, x and y intercepts. So remember we get x-intercepts when y is 0. So if I have 0 equals 2x plus 3 over x minus 4. We multiply the denominator over. But what's anything times 0? 0. And then we solve. Subtract 3 from both sides. Negative 3 equals 2x. Divide 2 from both sides, right? Because we're trying to get the x by itself. There you go. So we have an x-intercept of negative 3 halves. Now, if I want the y-intercept, remember that is where x equals 0 forever and always. So I have 0, excuse me, y equals, pardon me, y equals 2 times 0 plus 3 over 0 minus 4. So that ends up just being 3/4. So that's my y-intercept. Okay, so that's 1. 2, find the vertical asymptotes. Recall, vertical asymptotes come from the denominator. So I'm just going to grab the denominator of x minus 4, set it equal to 0, and solve. So that just is by adding 4 to both sides. X is equal to 4. All right, we're moving right along here. Then we have the horizontal asymptote. Remember, that is by looking at the leading terms and the degree. So the degrees are there, they're invisible. So the degree for both is what? 1. So that means they're equal. So the horizontal asymptote is the ratio of the leading coefficients. So that says we have a horizontal asymptote at y equaling 2. And again, I'm going fast because I already know all this. You just learned this, okay? So give yourself a break. You're going to do a bunch of page flipping up and down, moving things around. Be kind to yourself and just recognize it's not going to come to you immediately. You're going to have to put effort in to get this stuff from paper to learned. And then, okay, plot 1 point. So what I like to do is slap down some axes. And then I'll do my asymptotes. So 1, 2. Because remember, your boomerangs, your graphs, are basically following the paths of your asymptotes. Asymptotes? Asymptotes? I have no idea. Whatever. Okay, 1, 2, 1, 2, 3, 4. So here's my vertical. Doop-a-doop-a-doop-a-doop-a-doo. And then we have an x-intercept of negative 2/3. So here's negative 1, 1, 2, 3, 4, 1, 2, 1, 2. -1, -2. Okay, so x equaling -3/2, that's -1.5. So I'll just plop that right there. A y-intercept of 3/4, so that's what, 0.75. We'll just plop that right there. Oh, negative, no wonder. Hang on. Y'all probably screaming at me when I didn't have that negative. -3/4. So negative 0.75. So here. And then, so again, since I know that my parent function is some kind of like boomerang situation, like one of these up here, right? I know that we have this shape going on. It's probably smoother. There we go. There we go. Well, I guess I should point out, let's say like, let's just make sure. Is it up here or is my other boomerang right here? Let's find out. How do we find out? So that's 4, 5, 6, 7, 8. Let's just pick a number somewhere in there. So let's say x equals, what do y'all want? 6? So I'm just going to find f of 6 and see where it lands. So f of 6, that's 2 times 6 plus 3 over 6 minus 4. So this is 12 plus 3, which is 15, over 6 minus 4, which is 2. So 15 over 2 is what? 7.5. So 6 comma 7.5 is a point. So yeah, my original estimate was pretty good. So 2, 3, 4, 5, 6, 7, 8. So there's 8. So really we want 6 to be somewhere along. Right there. Okay, 4, 6 here. So let's get rid of this line. Get rid of these. Get rid of this question mark. All right. So the boomerang looks something like this. Doesn't have to be perfect. It's just a sketch, okay? I just need enough, like, do you know, is the boomerang in quadrant 4 or in quadrant 1? I said this backwards, quadrant 1 or quadrant 4. Okay, that's good enough for me. All right, you want to pause the video and try 5? Give it a go? Yes, no? Okay, so x-intercept. So one thing about the x-intercept is that it's basically always the numerator because it's where y equals 0. So from above, right here, right, y always equaling 0, and see how we always have the denominator 0 out? That'll happen every time. So essentially, you just set the numerator equal to 0 and solve for the x-intercepts. That's it. So 0 equals x minus 2. So we're going to add the 2 to both sides. X equals 2. All right, so x-intercept done. Y-intercept. Oops, y-intercept. That's where x equals 0 forever and always. So we have 0, oops, x equals, pardon me. Y equals 0 minus 2 over 0 squared minus 3 times 0 minus 10, which is just -2 over -10, which is a positive 1/5. 1/5. Okay. So y is 1/5. There we go. Now let's do vertical asymptotes. Excuse me, remember vertical asymptotes come from the denominator. So we're just going to factor the denominator. They come from, remember, vertical asymptotes are impenetrable walls that occur where the denominator is equal to 0. And in factoring, we'll see that no, there's no hole. Let's see, two numbers that multiply to 10 but add to 3 are 5 and 2. So -5, +2. Set both of these equal to 0 and solve. So we're just going to subtract 2, add 5, add 5. So x is equal to -2, x is equal to 5. So we have vertical asymptotes at 2 places. Horizontal asymptotes. So remember, horizontal asymptotes come from what's going on with the leading terms. So the numerator has a degree 1. The denominator is degree 2. So this is degree what? Top heavy, bottom heavy, or equal? Bottom heavy. What does bottom heavy imply? Let's see. So just this is what you're going to have to do in the homework, okay? So it implies that we are where bottom heavy here, right? The horizontal asymptote is 0. One more. Horizontal asymptote is 0. Okay. So then we'll pick a couple of points. But again, first, I just like to kind of get my axes slapped down, my asymptotes handled. So here's my horizontal. And then I have an x-intercept. Let's just throw down some 10 by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, that's not to scale. That's okay. All right, so vertical asymptotes at -2 and 5. 1, 2, 3, 4, 5. Okay. An x-intercept at x equaling 2. Y-intercept, oh, that's y-intercept. Hello. There we go. X equaling 2, better. Y-intercept of 1/5, so that's 0.2. It's right there. Okay. So now we just want to do some test values. So maybe let's do f of something over here. Let's do, I don't know, -4. F of -4, that works. See where that pops out? How about f of -1, right? See where that point is. Maybe f of 3. And let's say f of 6, because that's 5, here's 6. See what's going on. Maybe f of 7, who knows? We'll see. Okay, I am just going to pop it into here and look at my table. So alpha y equals 1 to get my fraction. You can just always do parenthesis, x minus 2, close parenthesis, divided by x squared minus 3x minus 10. So then if I go into my table, I already have it on auto. I can do -4, enter, -1, enter, 3, enter, 6, enter, and I could even do 7. Let's delete that one out. Okay, so -4, that's -1/3. And then -1 is 0.5, -3 is -0.1 or a tenth. 0.5, -1/10, right? That's -0.1, and I missed 6. Oh, positive 0.5, 0.5, that's good. So 0.5 is here, 3, 1, 2, 3 here, and -4, 1, 2, 3, 4 is -1/3. So let's call it there. I think that's it. Okay, so that's all I need. Because remember my horizontal asymptotes? I'm going to follow this line, and my vertical asymptote tells me to follow this line. I don't have any x-intercepts over here. So I know that I am a boomerang completely above the x-axis. Oops, forgot I was a highlighter. So I'm just going to come down. Whoops, hopefully yours actually goes through like this. It doesn't have to be perfect. It's just a sketch. And then I know that here I have to just basically pass through all of these points. There we go. Whoops. Here we go. All right. And then we can look at the graph to verify. Graph. Yep, there we go. Again, so on a test, basically, we're not really, I'm not going to give you a graph and say graph it because some of y'all have graphing calculators, and that's not really fair to those of you who don't have graphing calculators. So there's not going to be a whole lot of graphing in the sense of like, here's a function, now graph it on a test. There are workarounds, there are workarounds. Basically, it'll be like, where's the horizontal asymptote? What is the vertical asymptote? What's the X or Y intercept? Basically, like piecemeal questions rather than a full on, here's an equation, now graph it. Because again, you have graphing calculators, and I'm not interested in can you do a graph with a calculator? It's more of like, can you actually interpret this information? Like domain and all that fun stuff. And optional. For sake of time, we'll skip over it, but it is in the files. It's in files. I believe it's in files. Notes, maybe not. No, I think it is. Files, notes, in Canvas. Again, you can just graph it. You can practice and then graph it for yourself to double check.